Greetings folks and welcome to the Electromaker Show. This is your midweek roundup of all things embedded and maker and all the lovely things in between. Now, it's been a big week for releases in terms of single board computers, which of course we will be covering along with some projects, a few other things, and the mystery box competition. So let's get on with the show. So to start off this week, we're going to talk about the two big pieces of news in terms of hardware that's been released this week, and we're going to begin, of course, with the Raspberry Pi Compute Module 4. Oh, by the way, welcome the newest member of the show, Mr. Heater. The winter's going to be all right after all. Shush. But yes, as I'm sure many of you already know, the Raspberry Pi Compute 4 module is now on sale, and it starts at only $25. Now, every Raspberry Pi since the Raspberry Pi 3 has had the smaller form factor compute module, which you can slot into boards using the connector that they have. And it's essentially the same machine, it's just the smaller kind of system on module version, not dissimilar to the way that the Google Coral Dev board had a system on module. And we will be getting to the Google Coral Dev Mini in a moment. But yes, this is massive news. There's many different variations of the Compute Module 4, and I'm not going to go over all of them, but this is a massive step up. This is going to be huge for people who are into retro gaming. If you think that there were some crazy retro gaming handhelds before, they're going to get even crazier, even smaller. There's going to be a lot more features in them because these things are going to be so much easier to use. But just to very quickly run through, it's got a 1.5 GHz quad-core 64-bit ARM Cortex-A72 CPU, video core VI graphics supporting OpenGL, 4K 60 frames per second hardware decoding of H.265, which is the new hotness. At some point I might talk about video stuff on the show. Is anyone interested in video stuff? I do a lot of video stuff. Anyway, dual HDMI interfaces, resolutions up to 4K, single line PCI Express 2.0, dual MIPI DSI for display, dual MIPI CSI for camera interfaces, and yes, as you can see, many variations for RAM, many options for onboard storage, and there are options for Wi-Fi connectivity and Bluetooth as well. Yeah, this is just huge. The compute modules have always been really cool, but when you put them up against some other kind of system on modules that you can get from other places, I think a lot of people don't necessarily see the benefit. The Raspberry Pi is such a perfect form factor thing with everything you need. It is a mini computer already. You can plug everything into it, and as many people have shown with various articles and videos, you can sort of replace your desktop with a Raspberry Pi at this stage. These have always been a little bit different. But yeah, there's a few other things as well, like this I/O board, which is sort of a weird thing in a way because you're taking the Raspberry Pi and then turning it into a tiny little board and then putting it back onto a board for I/O, but that's important for development. There's a few of those actually. We'll be talking about those in this show as well. But yeah, I couldn't really go through the start of the show without talking about this. It is huge. The fact that it starts at $25 is incredible, and that's for the light variation. And by the way, if you are interested in all the different variations, there are 32 of them, and there is a product brief linked to this article which tells you about them all. And as you can see, they're split into whether they have wireless connectivity or not, and there are complete options for each variation. So the lightest version is 1 GB of RAM and light, which presumably means it has no onboard eMMC storage, which is fine. Yeah, right through to the beastie 8 GB of RAM, 32 gigs of onboard storage with wireless connectivity, which is still only $90, which is amazing. Did I say 32 GB of RAM? I meant 32 GB of onboard storage. I did. So yeah, these things are obviously kind of exciting. They really do kind of stand right between the completely maker-oriented and easy to use, just Raspberry Pi, does what it says in the tin, and then the system on modules that are designed to be kind of put in place for development and then used out in the wild. It's a super exciting time. We're really getting to that point now where everything is kind of getting together as a sort of one thing. All of the companies that make very impenetrable stuff are trying to make things easier for the consumer and hobby market and people like us. And Raspberry Pi are pumping out these things which are just super powerful and yeah, in their own right, just worth the attention of not only us, but people in the industry who need that power. And just because someone is trained in computer science and knows what they're doing doesn't mean they won't appreciate the fact that the Raspberry Pi has a huge online community and lots of documentation. Yeah, this is an exciting time. You won't need to look far for information about the compute module 4. It's by far the biggest story in embedded DIY hobby, kind of everything in that region news for this week. But I will leave a link to the blog on the Raspberry Pi blog. Up next, the Google Coral Dev Board Mini. Now, the original Google Coral Dev Board, of which I have one here, was one of the real trailblazers. It was one of the first sort of AI-capable single-board computers, at least one of the ones that took it very, very seriously, and that was absolutely down to the fact that Google has its own TPU edge computing chip, which is on this little system on module. And again, much like the Raspberry Pi compute module we were just talking about, I don't know how well you can see on this camera, but this little heatsink and fan are attached to a little module here, which I would pin off, but it's actually screwed down. And so this is a development board underneath, which can be hot swapped out, and you can put different modules on it. A little bit like the development board for the compute module we just looked at a second ago, and we'll be looking at some more in a moment. But the DevBoard Mini, starting at $99.99, is kind of an upgrade and a downgrade. It's much smaller, which is kind of awesome, and it still has the 40 GPIO pin connector, which is nice. So there's a few differences here. Basically, it has more RAM than the original Coral Dev Board, which only had 1 gig, although that will be changing soon. There are 2 and 4 gigabyte variants of the original Dev Board coming, but it does have a slightly slower processor. And that slightly slower processor is a MediaTek 8167S system-on-chip quad-core ARM Cortex-A35. Which is still no slouch particularly. And the question you've got to ask yourself is that since this is a board designed for AI inferencing, a board designed to be used in headless mode for the most part, and it does have the Google Edge TPU coprocessor on, which as you can see here is capable of 4 tops tera operations per second, or 2 tops per watt. I don't necessarily know whether the slower chip is going to be too much of an issue. It depends what you're going to be using it for. Again, for me, these boards are learning tools. I spent a little bit of time messing around with TensorFlow. I haven't had the time to really get into the weeds and learn everything properly. I've talked about that many times in the show. I would love to get into AI and really understand it, but beyond making a few toy neural networks in Python and beyond a little bit of messing around on TensorFlow, using the Google Coral Edge dev board, and my Raspberry Pi with the Google Coral USB accelerator, of which I have one as well, that's as far as I've got. These are going to be really interesting in my mind, because again, you've got that uncanny situation where it's in between 2 things. There's going to be the system on modules that work with the development boards, like I've said before, but now there's this miniature version of this board as well, so maybe people will just use this instead. Either way round, yeah, $99.99 for this is a fantastic price, and it is a variant on what you would get with the compute module. You can use this probably a little bit easier than a compute module because you can plug things straight into it. As you can see, it has a 3.5mm jack. It has these combi USB-C ports. It has a mini HDMI port and the GPIO pins, as I said. But there are differences between the two. However, there is a third option which is coming up, which is in a way even cooler and even more exciting than both, although it will mean you'd have to make a choice between the Dev Board Mini and the Raspberry Pi compute module. Because Raspberry Pi are not just putting out the new compute module, they've collaborated with Gumsticks to make a bunch of extra boards you can plug the Raspberry Pi compute module into, and there are a lot of them. And once again here on CNX Software, which as I said last week, CNX Software is an indispensable website if you are interested in getting the newest news about anything hardware and embedded. They do reviews as well, and I just discovered they have a Patreon, which I am now patronizing them. Yeah, there are a precious few absolutely no-nonsense news websites on the website for our kind of things that we love, and this is absolutely one of them. I would suggest checking them out. But yes, Raspberry Pi have now created many boards that work with the system on module board. So this is the first example. There's actually 2 here, the Raspberry Pi CM4 UpRev and UpRev AI. Pictured here is the UpRev AI version. And do you see what I mean about how things are about to get super interesting? Because we just talked about the Dev Board Mini, which has the Coral TPU on it. The main draw of these Google boards was the Coral TPU, because the development board itself it's all right, but if you're going to get just the development board, then why wouldn't you get a Raspberry Pi or Rock Pi or any of the above? The board itself was never the draw, it was always the TPU, and now here's this version that you can plug a Raspberry Pi compute module into and have a Coral TPU, and it has this edge connector which allows you to connect it to other things. Now that might not seem all that useful to you, but down here we have essentially something that turns the Raspberry Pi compute module back into a Raspberry Pi. So you can actually have both things here. Now, there are various different options they've reported on here. This is the Robo version, which is a small robotics breakout board, which has connectors for Raspberry Pi touchscreens. It has connectors for cameras and mini HDMI. It has everything. It's just in a much, much smaller form factor, as you can see. And there are a bunch of other variations, which is why I was kind of saying at the start, this is such an interesting time for releases with single board computers, because things are starting to kind of cross over a little bit. There's going to be the Coral Dev Board Mini, and it's going to be a great board, but do you really need a Coral Dev Board Mini if you can then get a Raspberry Pi compute module and you can get this thing with a Google TPU on it? Now, admittedly, the one that I showed just before has an Edge connector, so it's not quite the same, but I wouldn't be surprised if they released a base board a little bit like this, which also had the Google TPU coprocessor on it. And if it did, then things are going to be mad, because you're going to have Raspberry Pi ecosystem on one side, but you're going to be able to use it with the onboard Google Edge TPU. That sort of would be a shot in the foot for the Google Coral Dev Board, but if they're selling their TPUs to the people who are making these Raspberry Pi breakout boards, would they care? I don't know. Can you tell I'm a bit excited? One thing is absolutely for sure. If you are interested in learning about AI on single board computers, it is getting more and more accessible to people, again, like us. When I say us, I really just mean me. I really just mean the untrained masses who are enthusiastic, but not necessarily someone who's going to be doing this as a job anytime soon. And yeah, this idea of hot swappable development boards where you can take system on modules on and off. Right now, there isn't really any way to swap them out between each other and use them. But I wonder whether that might happen in the future. I wonder whether this is all going in that direction, where you just have very nice little boards like this that you can just sit on a table, and then you can slot on and slot off different things, a little bit like Arduino shields. But rather than Arduino shields, you're slipping on and off entire system modules. I really like that idea. It's really cool. But anyway, my postulating about the future aside, I will leave a link to the CNX software article in the description, and it is, as always, very, very detailed and takes you through all of the different specifications of these different boards. As you can see, there is also a power over Ethernet smart camera here, which is a nice touch. And yeah, so if you do want to read about this, I will leave a link in the description. Very quickly before moving on, I don't want to labour the point, but this is an Electromaker thing, so I do want to mention it again. If you haven't checked out the great PSoC6 challenge page on the Electromaker page, this is the latest Electromaker contest. It is using a bunch of Cypress Semiconductor's development boards, a couple of which I've written about in the last couple of weeks, and I've been getting to know a little bit. I might do a full video on just maybe one of the pieces of hardware at some point, so I can show you what they are like to use. They're very lovely little devices. But the competition itself is something that, if you haven't already checked it out, have a look at it. You can win up to $1,000, and just by entering, you could get a free kit. And yeah, as I've said, they are actually very, very nice, very high quality development boards. And now let's move on to a section of the show we like to call Funding Website Things, where we look at things on funding websites. And starting, as we frequently do on Crowd Supply, PixelBlaze version 3 is pre-launch, and this is super exciting, at least to me. This is Wi-Fi enabled live codable LED controller with a web-based development environment. What does that mean? Well, I can show you. So what you're seeing is an app on the right side of the screen and live video of an LED strip on the left. And as you can see, you can just swap between these things in the app, and you can create them in the app as well. The idea is that you can swap these patterns on the fly and even create them even if you are not that familiar with coding. It's a great idea for a project. And as you can see, these things are pretty small. There's 2 variants available, or will be 2 variants available, depending on whether it gets launched or not. Although I'd be amazed if this one doesn't make it. I mean, look at it. But yeah, there's the normal sized PixelBlaze, and then there is the Pico PixelBlaze, which is a much tinier version, both based on the ESP32 chip. And it looks like they're putting out a sensor expansion board as well, which is great, because what's more fun than things that are reactive? You could put an accelerometer on it and move it around, and that would change the light strips, or you can make it sound reactive, or yeah, there's a million and one things you can do with LEDs and input. It's one of the first things that you learn when you are learning how to mess around with LEDs, is how to attach one sensor to another. The idea with this is that this is just a nice one size fits all solution for it, which if you aren't familiar with coding, you can still use. Now, I should point out what you're seeing in the video with them switching all of these LED patterns out. This is just once you've already made the patterns. You're still going to have to get in the weeds a bit with code in order to make it. But PixelBlaze, this isn't the first iteration of PixelBlaze, by the way. You probably realize that by version 3. PixelBlaze has been designed so that it's quite easy to use live. And in fact, actually, if you look at the PixelBlaze website itself, yeah, you can see that it has its own editor, and from what I can tell, the editor has been upgraded even more to make it easier for people who aren't necessarily that familiar with code. But I mean, if you've worked with LED strips and Arduino before, then you're already there. You'll find this very, very easy. The thing about it that I find the most exciting is the live coding element of it. Now, if you aren't familiar with the live coding crowd, the best place to get into it maybe is to look up Algo Rave on YouTube, or just any kind of live coded music using programs like Tidal Cycle. The most famous one that most people know because it comes with the Raspberry Pi is Sonic Pi. You code, and in real time while you are coding, the code affects the music and changes it. This is the same, but for LEDs. There are a lot of things about this project that I like. I think I've made my enthusiasm clear. I will leave a link to this launch page in the description so you can read through it. And even if the live coding side of it doesn't necessarily appeal to you, if you're just looking for a nice, fun way to easily affect lights on an LED strip, this will definitely do that. And the Pico version, as I mentioned before, is absolutely tiny, 11mm by 33.3mm. And yeah, I'm a massive fan of easier ways to interact with LED strips and lighting, and this appeals to me. So there'll be a link to it in the description. Moving on to the Onion Towel Lidar camera, which is a bit like a webcam, but it is a depth of field camera. And when I say depth of field, what I mean is depth sensing camera, because obviously there are a lot of different things to do with cameras, and I've just mucked up 2 phrases, one of which is obviously to do with camera lenses. This is more to do with sensing depth. But yes, first things first, can we just appreciate how cool this thing looks? There's some real nice aesthetic design that's gone into it. But yeah, to get a kind of rough idea about what it does, there is a video that shows that in the browser you can get depth sensing from this camera in relatively good time with a relatively decent FPS. It says here that the depth stream output frame rate is 30 frames per second, which isn't actually bad for this kind of thing, because yeah, LiDAR time of flight is it's a bit of a dark art to get into. There's a lot of off-the-shelf things that work wonderfully, but yeah, it's not as trivial as I thought it would be, having tried and failed to get it going a couple of times. But yeah, this once again, this is a nice entry point, and if there was one thing about this that I was to say would make it really appealing to the maker markets, to people who are interested in just having a go, is the fact that it is USB plug and play, just like a webcam. And you get this nice 160 by 60 array of depth nodes. And by the way, this is compatible with OpenCV as well, so I haven't really got my head around exactly what that might mean at this stage, but I do wonder whether you could do some kind of depth-based object detection. I mean, obviously you couldn't classify anything with 160 by 60 pixels, but I wonder, yeah, that might be an interesting way of sort of counting things by distance rather than counting things using artificial intelligence. I don't know, just a thought. Anyway, once again, much like the last one, this has not been launched. When both of these do launch, I will redirect you back to these pages, or you can just bookmark them, or even follow them on CrowdSupply. I don't know if I've mentioned this, but generally, if I'm interested in something, what I tend to do is just enter the subscribe box, because CrowdSupply aren't particularly spammy whatsoever. You'll only get a message about this when they update the project. So if you are interested in it, you can of course subscribe, but there will be a link to it in the description as well. Before moving on, I just want to mention RoverWing again. I'm not going to go into it because I went into it in detail on a previous show. It did reach its funding goal, and there are only 9 days left of the campaign. So if you do want to actually get in there before this campaign ends, by the time you see the show, there'll probably only be about a week left or so. So get in there. Yeah, this was one of the ones that we talked about on the show a while ago. Just a really nice shield for working with robotics with the Adafruit featherboards, and I know many of you are users of Adafruit featherboards, and as am I now. I've kind of got into them recently. I did buy one to try out a few different things, and it is a really nice platform. So yes, Adafruit featherboard compatible, robotics, good, nice. It's gonna be done soon, go. Moving over to Kickstarter, and a project which is a little different to many of the ones we've covered on this show in the past. In fact, I'd probably, if I'm being honest with myself, this doesn't necessarily fit with the direct maker and embedded culture. I mean, I know as makers we like tools, but this is an open sourced CNC machine, which is probably a little larger in scale than the things we usually talk about in the show, but I think it is definitely worth your attention for a number of reasons. So Maker Carver, which is based in Denmark, is an open sourced CNC machine. Now there's various ones of these available. There's various designs for open source CNC machines. And I can't necessarily say why this one over many of the others has grabbed my attention so much. I just feel like there's various hallmarks of this that fit with me. It's not just the thing that they're trying to make, it's the fact that it uses open builds. And if you're not familiar, Open Builds is an online community sharing tips, tricks, and designs, and everything you need really to build your own tools. It is a community designed to share open sourced hardware and software for creating your own manufacturing tools at home or in your workshop. It's a great community and it is a great project. And Maker Carver is using parts all from the Open Builds site. So I should mention that this started life as a project with 2 university students. This to me doesn't seem like someone's throwing out a CNC machine to try and make some money. This has definitely been a labor of love, and I think it's just a labor of love that he wants to share with people. But yeah, again, as usual, I'm not going to read through detail after detail. Hopefully you can just see from some of these pictures that this is definitely a very robust looking machine with a fairly decent sized work area as well. A lot of the kind of hobby small CNC machines they're great, but they're almost like toys really. You can maybe carve small cases for things, but yeah, this has got a little bit more to it than that. But yeah, it's just a very well put together idea. But here's the thing, there's another one of the reasons why I didn't necessarily think this would fit in the regular show, is that most of the things that I show you are not that expensive. If you really want to support this, you're going to have to put down a fairly significant amount of money. Certainly nothing compared to a professional CNC machine by any means. But yeah, the lowest reward where you actually get something is the spindle and the holder, and that comes in at around €307. And if you want to get the full kit with everything involved, it is around €640. So this is definitely a lot more expensive. This is more if you were thinking of getting a CNC machine anyway, interested in building one yourself and want to support some people that are trying to put out a design of theirs that seems to work very well. Just a note, by the way, there are also various different forms of reward. There are different sizes of this CNC that you can get. There is a 1000 by 1000 millimeter version of it, or of course meter by meter version of it, which is again relatively large for a homebrewed CNC machine, which costs again around €670. But this is something that if I was looking to buy a CNC machine now, I'd certainly be looking in this direction. I don't think I want to get an off-the-shelf model when I get one. I do want to make my own, or at very least get one from a kind of open hardware place where it's people who have been perfecting something that they love, rather than a company that's trying to throw out the cheapest CNC machine that they can. But yeah, this is definitely a little bit above the price spec of our usual show, but it is something that I wanted to share with you because this is obviously a project that has had a lot of care and attention put into it, and I do wish them the best. I hope they manage to get it out there. That said, when you see this show, it will be very close to the end of its Kickstarter. It says 3 days to go by now. By the time the show goes out, that's going to be down to 2 or 1 days, and they are not even quite halfway to their €8,000 goal yet. So if you do want to support this project, I will leave a link to it in the description. I do understand this is a lot more money than the things that I usually recommend on this show, but it's a project that I think is worthwhile. Moving on to another Kickstarter, this time from Mexico, and this is Cardbots. Now, there are many cardboard-based robotics learning kits out there, but this one grabbed my attention for a couple of reasons. Firstly, I like the simplicity of it. It's essentially just a Bucky robot controller, as you can see in the top right of the video here, an app, as you can see in the bottom left, and a bunch of plastic but biodegradable clips for clipping cardboard together. Although, you will have to provide your own cardboard, I'm afraid. But yes, small-scale kits that combine household items with simple electronics and simple-to-use apps in order to get kids interested in mechanical engineering or programming or any of the things that are included in this. Anything that, if you think about what is behind the scenes of this, there's the programming of the app, and there is, of course, the robotics itself, and any one of these things might be interesting to a child. In fact, there are a lot of people out there who are of the correct age now, who are now working as programmers and had their start using block-based code like Scratch, for example. It does actually work to get people in. Oh, and just as I said, that Scratch appeared on the screen. it does actually work to get people interested in this kind of stuff. And of course, kids don't have to be interested in these kind of things, but as a parent who is into maker culture and all of this, I would like to give my son the opportunity to get this kind of joy for himself, rather than me kind of hopefully pushing it onto him, because obviously that's not the best parenting in the world. Anyway, my dad worries aside, this is a fantastic project for kids and adults. I mean, it doesn't have to be kids necessarily. The idea of making things with cardboard and making them move is something that still makes me kind of giddy. And it's something I wish I put the time aside to do more, because of all of the mad projects that I want to do. Grabbing a few motors, clipping them together, and getting a cardboard tank to roll across the desk is always fun. And yeah, as you can see from this video, it's very easy to use. It's a really, really nice looking app. You can just sort of drag and drop things and connect them together before sending it to the cardboard, as you can see here. So they put the circuit together, they press a button on the app, and it triggers the bucky, which triggers the little motorized wheel. This is something so simple that even younger kids can sort of get the idea behind it and hopefully get excited by it. So the Cardbots kit comes in at around €73, and for that you get the Bucky robot controller and also a bunch of those little clips. And I think given that you will also of course have access to the app, which works natively with Bucky, I think that's actually a pretty fair price. I know a lot of these cardboard kits, people kind of scoff at the cost of them, because essentially you're selling ways to attach bits of cardboard together along with a microcontroller. A lot more goes into these projects than that. To get any project like this accessible to children and easy to use by kids takes a lot of development and a lot of thought, and that's where your €70 will be going. It's worth noting, by the way, that this €73 price is the Kickstarter limited edition price, which is 40% off. They'll also be selling classroom bundles, which will obviously cost a lot more because you need to get equipment for a whole class full of people. But I presume that means that they'll have a fairly robust educational side to this as well. So at the time of making this video, they are around a third of the way to their Kickstarter goal. Now, you will obviously have to make your own judgment call as to whether you think this is worth the money they are asking for it. However, most robotics kits for kids that I've seen that are cheap are not really that well aimed at kids. The hardware side of it is fine, but really it's just a robot kit, and where it might have some scratch integration in one place or the other, a lot of them don't have very clear instructions as to how to get it all working, and it appears that this one might be different. I could be completely wrong with that. I will leave a link in the description so you can have a look and make up your own mind. Yes, that's right, it's time for the mystery box competition once again. So, you know how this goes. This is a box of mystery things. We've been giving one away every week since the show started, and this week is no different. So, to enter the competition, you just leave a comment on the video. It can be any comment whatsoever, you don't have to say anything specific, but this week's prize is going to be an Adicup 360. An Adicup 360. Now this is from Analog Devices. Now I have never actually owned one of these, but I think I know what this is. They are these little ARM Cortex M3, I believe, boards. Oh, this one has something extra on top of it though. This is a Wi-Fi shield. Oh, cool. Well, as always, I want to make sure I know what I'm talking about, so I'm going to quickly go and look this board up. Yes, as I thought, this is a little ARM Cortex 3 equipped microcontroller made by Analog Devices, and this one comes with a Wi-Fi shield, which it fits on top of it. These pins, by the way, are Arduino compatible, so if you have Arduino shields, it will work with them. There is an open source IDE for this, along with a user guide that you may be seeing on the screen right now. And so I will make sure that you get links to that if you do happen to win this. It also comes with a USB stick, which presumably has examples and software on it. I would download them rather than this, because I imagine these will be out of date by now. But these are quite cool little boards, actually. I considered getting, maybe not exactly this one, but something similar a while ago, because I was interested in getting into actually programming ARM Cortex chips. And then, of course, time. It's always just time. Anyway, I'm waffling again. We need a winner. And this week's winner is Colin Russell Conway. We'll be in touch with you as to how we can get this thing out to you. And by the way, as your comment says, you've been looking into building DIY pedals, and so have I. In fact, I have built several over the years, but there is one in the pipeline that we will talk about on the show. But enough of that. This is coming out to you. Congratulations for winning, but for now, let's get on with the rest of the show. And to close out this show, let's look at a few projects from this week. And we're starting with a project by Curious Human on the Electromaker website, and this one is a big one, the DIY NanoLeaf. Now, when I say big, I don't necessarily mean the project itself is big. I just mean that the nanoleaf lights that you've probably seen reviewed all over YouTube, they're those lovely panels that fit on the wall and are reactive. They're really nice, but they're so expensive. And this is a very functional DIY version of them. So this is what I'm talking about. You can see in the background of the image, these are the panels which fit on the wall, and they are very striking. They are very nice. It's a very nice way to add some ambient light to a room. So this DIY version of the nanoleaf, which the maker calls Vrixa, which is Sanskrit for tree, I'm sure I pronounced that perfectly, is actually really nice. It's really simple in the way that it's done. The panels are 3D printed, and the LED strip is just a normal LED strip which you would have a remote for, and you can affect them using the remote. The thing that's really good about this is the design of the panels and the way that the LEDs all fit together in them. And the build guide shows not only how this was put together, but the journey of discovery that Curious Human went on in making 3D models, because this was the first time they'd actually made 3D models for one of their projects. So by searching online, they found the nanoleaf rhythm, size and dimensions, and so they could make their own, and also researched how nanoleaf attach their LED strips together. They use these LED strip connectors. Oh, and by the way, if you were interested in getting the 3D model of these nanoleaves so you can make one yourself, there is a link to GitHub here where he has put the Fusion 3D and the STL file for it. So Curious Human got the 3D models printed online and sent out to him, and you can see here the process of diffusing them and then sticking the LED strips around the inside. As I said before, this is a very simple design, but simple isn't necessarily bad. In fact, as I've said many times, simple is usually best. And much like he showed earlier in the article, he uses solderless connections in order to connect all the LEDs together, which is a very nice way of doing it, because it means that you could hot swap this design out, you could change it whichever way you wanted to. I think in the article he mentions that he did actually stick them together into this one way, so it had a bit more rigidity, but if you worked out a clever way of putting it on the wall, you could change the shape of this any way you liked and just rejig all of the solder connectors using these solderless clips. There is also a very detailed video guide on the build page, which takes you through all of the steps that I just talked about, so you can read it and you can also watch the video if you decide you want to build one of these things yourself. But as always, I found that myself watching this, there's also a very detailed video on the build page if you would like to watch a video version of this build as well. As always, there will be a link to this build in the description of this video. Staying on the Electromaker site, this is a smart blinking ID card. And this one actually sort of blew my mind slightly because it uses something that I didn't know existed, but I had just completely forgotten about. So this project is made by Ashokra, and I'm sorry if I'm mispronouncing your name, we have had you on the show before, and it uses LEDs inside a ID card badge along with an NFC sensor. And this is the thing that I had forgotten about, but that is actually a thing. These NFC cards, when they do actually make a connection with an NFC reader, it powers the coils enough to light the LEDs. There is no battery inside this thing. It gets powered using, well, I'm just going to say magic, but realistically it gets powered by the coils in the NFC sensor getting activated by the reader. This one isn't actually a guide. It does say that he uses the N-Tag I2C antenna, which is from NXP, which is a fairly cheap and simple way of achieving something like this. I'm sure there are other ways you could do it as well, along with the fact that there are 4 SMD LEDs. It does actually say exactly how to do it. It's not a step-by-step tutorial, but everything you need to do this yourself is here. But yeah, just as I said, I had forgotten that this was a thing, and seeing this completely blew my mind. I spent a fair bit of time trying to work out how it was done before remembering that yes, this is something that exists. And while it is a bit of an old article, if you are interested in this kind of thing, there's an article on NFCW titled Passive NFC Chips Can Power Light and Sounds. And this just, again, basically says the same thing as the article. I just had to look it up to remind myself that this isn't witchcraft, this is just normal electricity. And moving on to a couple of projects I saw on Reddit this week. This first one is wild. This is an aimbot using a Nerf and a Raspberry Pi. There's been several kind of object tracking things that maybe use a couple of servos that we've seen. There are lots of projects and they're great projects to try out for yourself, but this one is so over-engineered, it's incredible. As you can see, it has a little laser sight, but as you can also see, it can track moving targets, compensate for their speed, and fire at them. Now, this is a very, very nicely made thing. It is so smooth. It's almost gimbal smooth, which is, yeah, just incredible. There's a little bit too much to unpack in this for me to really go through it all, but essentially this is Raspberry Pi powered. and all of the code for it is up on GitHub if you are interested. And there is also a very full video for it as well, which is linked in the comments of this thread. And if you are interested in making one yourself, there is also a GitHub for the project, which is linked in the video description of the YouTube video, which talks about coming from CSGO and getting killed by someone with an aimbot and deciding to make one in real life. And yes, as I said, there's a lot to unpack here, but this went through a lot of iterations in design. This is an incredibly over-engineered project, and I love it so much. And yeah, forget what I said about things being simple. No, complicated. Complicated is way better. But yes, the aforementioned GitHub not only has all of the code, it has all of the 3D printed parts you need as well. And there is a lot of them. But if you have a 3D printer and a Raspberry Pi and are a fan of Nerf guns and want to build this for yourself, there should be everything there you need in order to build one yourself. But as I say so often on this show, this video is entertaining, it's well put together. Even if you have no interest in making a Nerf gun blaster using a Raspberry Pi, this video will entertain you, and it is a link in this Reddit thread that I will put in the description of this video. Our last project today is on the Synth DIY subreddit, and of course I've made no secret of how much I love making DIY music making devices using microcontrollers and all of those things. I talk about it almost every week, it seems. This one though is particularly special. It's based on an idea that I think many of us in the DIY music making community have had before, but none of us have actually implemented. And that is using a touchscreen to make a wave shaper. And now, wave shapers are basically just you draw the wave, and that is the wave for your synthesizer. You're probably familiar with the idea of having sine waves, square waves, triangle waves to get different tones on a synthesizer. This allows you to create synth tones and combine them, and it's just fascinating and astonishing and wonderful. So seeing this makes me very, very excited. The idea of being able to just draw in your own wave shapes isn't actually anything new. There's been software versions of this for a very long time. There are plugins for almost every software DAW out there that allow you to wave shape on the fly and create and combine different waves to make new kind of synth tones. But this is obviously more in our area of the Maker DIY way of doing things. And luckily, the Maker is very much behind that idea as well. As they say here in the comments, they've created a Google form for anyone to fill in if they're interested in the project. They're going to release them as full modules, but also have the software and hardware design available on GitHub when it is ready. So the idea being, if you just want one of these for yourself, you can buy whatever this thing turns into. Presumably they'll make it into an actual instrument in a box itself, or you can just go to GitHub and get the code and make whatever version of it you want for yourself. But I've mentioned a few times on this show this idea of learning digital signal processing and how to make music with code. And I understand that if you're not necessarily into it, you might wonder, why would you need to know that kind of stuff? And this is why. Taking the input from a touchscreen and turning it into sound is just astonishing to me. It's a project that I really am behind, and I look forward to seeing where this one goes. That was our show for this week. Thank you so much for joining me. This show is here every single week, and if you are enjoying it, I would appreciate you sharing it with your friends. We are trying to grow the show, but we're trying to do it without being particularly scummy and asking people to share it everywhere and like and subscribe, and without getting horrific large advertisements. So if you are enjoying it, please do tell somebody. But yes, for now, I just hope you have a fantastic and creative week. As always, regardless of the mystery box competition, I'd love to know what you are getting up to. If you are working on projects, do let us know in the comments, although of course that would still enter you for the mystery box competition. Anyway, I hope you have a fantastic, safe and creative week. Take care.